Welcome to Pre-Calculus. In this lesson we will use the law of sines to solve oblique triangles. Oblique triangles are triangles that are not right. In other words, they don't have a right angle. So this is an example of a triangle, and it's important to label them correctly and understand that the uppercase is the angles and the side opposite the angle has the same letter. So angle B is opposite side B. Angle C is opposite side C. You have to be careful with the C's because, of course, they look the same, so make them exaggerate that they are small. The side is smaller. Most of our lesson will be talking about the ambiguous case. This is a complication of the law of sines, but we will start with an easy example. The law of sines is given as 3 equal fractions, but you will only use 2 at a time depending on what you're given. For example, in this case we're given A's and C's, so we'll use A over sine of A equals C over sine of C. Now if you're given 2 angles, the very first thing that you're going to do is find the third angle. You know that in a triangle the angles add up to be 180 degrees, so you'll take 180 minus the sum of the other 2 angles. And now you have all 3 angles. You just need to find the 2 extra sides. So given the information you have, I wrote again this formula that you're going to use, just these 2 fractions. Then you're going to fill in the values, make sure you're in degree mode. Now I've skipped a step here, which you will probably want to do too because it's less writing. Whenever you have a fraction equal to a fraction, you're going to cross multiply and have A times sine of 96 equals 12 times sine of 42. And here I've already divided both sides by sine of 96. So you always have the 2 numbers that are across from each other divided by the third number that you have here to get the unknown value. And that's a shortcut you may want to take, or write every step if you need to. Then you have 2 sides, and all you need is to find side B. So there you take your angle, your B over sine B, and when you have a choice, always go back to given information. You're given the C and this angle C, so that's what you want to use in your next calculation so that you get more accurate results. Now the law of sines is simple, but when we are given 2 sides and an angle, life is not so simple. Because what happens here, if we're going to use law of sines, we're going to be given all A's and B's, and that's what this case is. And so if we have 2 sides and we have one of the angles, we're going to we're using sine inverse to find the second angle. Well, the problem is when we do an inverse sine, we could be in quadrant 1 because the sign is positive there. Or we could be in quadrant 2 because remember, any angle in a triangle can be either acute or obtuse. So there's some ambiguity there. Now what happens is there are 3 cases. We will take the first case where it's not even possible to form a triangle. And then we will also show the case where there's 2 triangles that could be possible, or maybe just 1. So now, just for the moment, ignore the picture because you're not going to be drawing these triangles. That's just there to give you an idea of what's happening geometrically. But if you look at this data that is here, angle of A equals 85, A equals 15, and B equals 25. You just start out using the formula like you would for the other problems, and then you start filling things in. And I want you to pause the video and actually calculate that and see what you get. Did you get approximately 1.66? So remember, the next step is going to be to do the inverse sine, and when you go to do the inverse sine of 1.66, what happens? Try it and see if you agree. You should not be able to do that calculation, and this is the situation where there is no triangle possible, so you have to stop. These, of course, are the easiest ones because it's not possible to continue. So I want to show you just basically what's happening here. We have angle A, which I've done with a protractor, is 85 degrees, and then side B has to be opposite angle B, and angle B is down here somewhere. We don't know exactly how long side C is. So here is side B that comes up here at 85 degrees and is 25 long. I use 25 squares, but whatever, centimeters, whatever you can use. Then we don't know angle C, so we don't know. Just think of this piece down here is side A, and think of it as just dangling here. We don't know what the angle is. It could be an angle here, could be an angle here, could be here and here. But I think it's obvious that no matter what this angle C is, you're not going to ever reach side C because it's just dangling in the air there. So there, it is not possible to make this triangle. The second thing that can happen is there could be two triangles possible. In this one, we have these values here where the angle is 21, A is 12, and B is 31. Well, you can see that I've done the same kind of setup. We have an unknown side here. We don't know how long that is. I've measured the angle A, which is 21, and that's opposite side A here. Well, we know A is 12, and we know B is 31, so this length is fixed. This is fixed at that angle, but we're not quite sure what angle C is here. But for this particular triangle, and you would see this if you could make a piece of tape or rope or something that was exactly 12 units long, and then kind of rotate it around here, there are actually two places where it's going to cross that side, which is fixed, but we don't know the length of it. So you're going to either have an obtuse angle here or an acute angle here, which is what happens when you do the math. So when you do the math, we use the fractions, set them equal to each other. This one turns out to be less than 1, so we know we're okay here. But remember, your calculator is not as smart as you. Your calculator will only give you the reference angle, which is an acute quadrant 1 angle. So what you need to do is use that and make triangle 1 out of that. That will be this outer triangle, which once again, you're not going to draw these. You're just going to remember that you're not done when you just found the acute reference angle. So just for sake of time, I'm going to write this in now. So working with the acute angle answer that we get with the calculator, we work on triangle 1, which is going to be, we have B1 equals 68 degrees. That's what our calculator gave us. We now have two angles, so C1 will be 180 minus the sum of those two angles, so that's 91 degrees. And then we use we're trying to find little side C, so we're going to use the C over sine of C1 that we just found equals A over sine of A. This is given information. You want to make sure you go back to the givens when you can. And then when we solve that, we get little side C equals 33.5. Just verify that for yourself. But we are not done, because that is only one of the possible answers. Remember, whenever we do inverse sine of a positive, we have a possibility that it could be in quadrant 2. Now, we often get mixed up because there's a couple of 180s hanging around here. We already used the 180 to find the third angle in the triangle, but this is the quadrant 2 180. In order to find triangle 2, we need to actually take that B, and I'm going to make it now a B2, to subtract the reference angle, so it'll be 180 minus your reference angle 68, and that will give us 112 degrees. Now at this point you really don't know if that's going to work or not, but your next thing is to find C2. So C2, once again, that now we're working on, we had the original A is 21, and then we have 112. So our third angle of the triangle is going to be 180 minus the sum of A and B2. A never changes. And that turns out to be possible. This is where you know if it's possible to have a second triangle. yes, there is another angle. These are uppercase, but I'll put angle marks to be sure. So then I will write the rest of it to finish this out. So now you've had all of triangle 2. We have angle B2 is the obtuse quadrant 2 angle, and angle CT2 works. That was 47 degrees. And we use the that same ratio, except we put the C2 in this time. Stick with your givens, A and sine of A, and then you end up with your side C2 equals 24, and you're done. The third thing that can happen is that there's only one triangle possible. Now I'll show you this in the diagram. Once again, you're not going to draw these. You just have to always look for the second triangle. There's no way around it. So for this particular set of information, we have the angle is 36, A is 8, and B equals 5. So I use the same letters so you could see the relationship here. We have angle A, we know, which is 36. We don't know how long side C is, so that's just the dotted line. We know, coming up at that angle, the B is 5. And we don't know angle C, but we know A is 8. And think of this. Think of this as being different angles here. Well, it's going to come below here. It's going to hit above here. It's not going to hit side C in two places like the previous one did. So this is geometrically what happens, which once again, you're not going to be drawing this. It would take way too long. So look at what happens algebraically. We have the same setup. We end up with sine of B equals 0.3674, which is less than 1, so that's going fine. And when we do our inverse sine of the answer, I suggest, by the way, if you're doing these, that you use ANS on your calculator. So you can just do a quick check of what sine of B equals, make sure it's less than 1, and then whatever's on your screen, if you have your ANS key, do the inverse sine of that, and that will give you your reference angle. And that is what we're going to call angle B1, and then we'll go from there. So here are the calculations for triangle 1. We had our reference angle, which is our acute angle, 22 degrees. And then we found the third angle in the triangle, 180 minus 22 plus the given angle, 36 degrees, equals 122. So that's those three angles in the triangle. Then we found little side C, once again using given information here, our little side C1 over the sine of this angle we just found equals 8 over sine of 36, and we get 11.5. So that's triangle 1. Now we look for triangle 2. Well, angle B2, remember angle B is the one that we did the inverse sine of, so that's the one where this is the acute angle. If we want the quadrant 2 angle, we have to do 180 minus 22, and we get 158 degrees. So far you have to keep going because nothing didn't work. You'll see. It won't work, because what happens is when you go to find angle C2, you remember that's the third angle of the triangle, so you do 180 minus, and then you sum up angle A, which was 36, that never changes, plus your angle B2, which we just found, 158. Now you might be seeing this already, but what happens is this is impossible because you will get a negative angle. So you can either stop when you get a negative angle, or when you see 36 plus 158 is already greater than 180, you know that's not possible. So you stop, and there is no triangle 2, and you're done. So that's the SSA. If you remember, SSA is a triangle that when you did congruent triangles, SSA was not one of the congruent triangles, and this is why. Because there's just too much ambiguity with two sides and an angle that is not included between the two sides.